This problem is to find the output resistance, R out, which is located here, the gain, AM, which is the midband gain, R in without RO, and the range at V naught for the output. So to start, let's just find R in first. R in will be here. And I've already drawn the hybrid pi for this. It doesn't really matter what's connected over here because nothing else is connected to that input. So the pathway starts at Vn and then moves down to ground. So there's this dependent source. To get rid of the dependent source, you use resistance reflection rule. So you multiply by beta plus 1 here. And your path then is R pi 1 plus 1k times beta plus 1. So now R pi is dependent on the current, and we are given a fixed current because the resistor is already set. So finding the current based on this resistor, right up here. So this drop is known, so 10 minus that drop, which is minus 10 plus 7. If I just do a full loop, I'll have minus 10 plus 0.7, and then the drop here, which would be plus to minus, so plus I times 10k, and then a minus 10 equals 0. So solving for I get 20 minus 0.7 over 10k, which is 1.93 milliamps. So now the rest of the currents are going to be pretty close to the 1.93 milliamps. It might be 1.91, 1.90, 1.89. So it's going to be pretty close to 1.93. So let's kind of put 1.9 milli. So R pi, which is what we're trying to find, is a beta Vt over Ic. And it will be of this first transistor. So using the active relationships, you can find the current here and then reflect it in. At beta equals 100, it's typically pretty negligible differences, so we're going to just say IC is pretty similar to 1.9 milli for both of them. So I am going to use the beta here and 25 milli and then a 1.9 milli. So plugging that in gives an Rn of 102.3k ohms. Now to find the output resistance, which is located here, I need to know the resistance seen on the top part and then the resistance seen on the bottom. So I need this resistance. And then down here, I have a little bit more complicated circuit. So I'm going to take two different resistances. I'm just going to first find this one, which I'll call R equivalent 1. And to find R equivalent 1, you can put on a test source on here, which we've already done in the past, and that equivalent resistance for this particular configuration was RO times 1 plus GM times this resistance, which is 1K, in parallel with our pi. And so RO is VA over 1.9 milli. 1 plus, and GM is found from IC divided by VT. 1K in parallel with, again, the 100 times 1.9 milli over 25 milli. So this gives approximately 51.5 K. So that's a resistance seen from this node to ground. So then I need to find the resistance now seen up at the top. So I'm going to call this REQ. And REQ is, again, there's an equivalent resistance here, so it's one transistor in the resistance, so it will be similar. Be RO 1 plus GM. This time now it's R equivalent 1 in parallel with R pi. And same thing, VA over 1.9 milli for this, and then this is going to be the same. And now this is 51.5 K, and this is the same. So the R equivalent is 25.9 megs. And so the R out will be that R equivalent we just found in parallel with the resistance seen on the top. This is a simple current mirror, so all that's seen up here is RO. So the midband gain now is going to be a minus GM R out, which gives a value of minus 98 volts per volt. So we found R out, the midband gain R in, and now looking at the range for VO. The range for VO is going to be the drop from here. This is 0.7. This is 0.4, and then across it is 0.3 volts. So it's going to be 10 minus 0.3 is going to be the max. And on the bottom, the minimum drop across each of these is 0.3. Then there's a drop here due to the 1.9 milli. So the minimum will be a minus 10 plus the 1.9 milli times 1K plus 0.3 and then plus 0.3, which is a minus 7.5 approximately. The max is going to be the 10 on the top minus the 0.3 across that. So 9.7 is going to be the max. Okay, so summarizing this, our out was the 25.9 meg in parallel with the 50 over 1.9 milli. AM was a minus 98, and our in was 102.3 K, and then the range for V out ranged from a minus 7.5 to 9.7.